Hello, and welcome to our lesson on comparing the value of fractions. In this lesson, our primary focus will be on understanding how to compare the value of different fractions. Here's a brief overview of what we'll cover. We'll start by recalling what a fraction represents and how we can visualize fractions to intuitively grasp their values. We'll then introduce methods to compare fractions, including finding common denominators and using cross-multiplication techniques. Finally, we will apply these methods to various examples to reinforce our understanding and improve our ability to determine which of two or more fractions is larger or smaller. In our previous lessons, we've built a solid foundation around fractions. We've explored what fractions represent, such as parts of a whole, and how they can be interpreted and manipulated in different contexts. With this solid foundation, we can now delve into the techniques for comparing fractions. For example, imagine a scenario where you need to determine which of two slices of cake is larger, one that is 3/4 of a cake and another that is 5/8 of a cake. By learning to compare these fractions, you'll be able to solve this problem efficiently and accurately. Let's get started. To effectively compare the value of fractions, we need to consider three distinct cases: fractions with the same denominator but different numerators, fractions with the same numerator but different denominators, and fractions with both different numerators and denominators. Let's break each of these down. We'll start with fractions with the same denominator, but a different numerator. When fractions have the same denominator, it means the whole is divided into the same number of parts. In this case, the fraction with the larger numerator is the bigger fraction. For example, if we compare 4/5 and 3/5, since both fractions are divided into 5 parts, we only need to look at the numerators. 4/5 means 4 parts out of 5, while 3/5 means 3 parts out of 5. Since 4 is greater than 3, we conclude that 4/5 is larger than 3/5. Imagine two pie charts, each divided into 5 equal slices. In the first chart, shade 4 slices, or 4/5, and in the second chart, shade 3 slices, or 3/5. It's visually clear that 4/5 covers more area than 3/5. Now let's look at fractions with the same numerator but different denominators. When fractions have the same numerator, the fraction with the smaller denominator is the larger fraction. This is because a smaller denominator means each part is larger. For example, a half is bigger than a quarter. For example, let's compare 4/6 and 4/5. Both fractions have a numerator of 4, but different denominators. 4/6 means 4 parts out of 6, and 4/5 means 4 parts out of 5. Since dividing something into 5 parts gives us bigger pieces than dividing it into 6 parts, 4/5 covers more of the whole than 4/6. So 4/5 is greater than 4/6. Picture two whole pies. In the first pie, divide it into 6 slices and shade 4 slices. In the second pie, divide it into 5 slices and shade 4 slices. Visually, 4/5 covers more area than 4/6. Now let's look at fractions with different numerators and different denominators. When neither the numerators nor the denominators are the same, we need to find a common basis for comparison. This is usually done by converting the fractions to have a common denominator. For example, let's compare 3/7 and 4/9. First, we need to find the lowest common multiple of the denominators. The lowest common multiple of 7 and 9 is 63. Next, we convert each fraction with this lowest common multiple as the denominator. Convert 3/7 to an equivalent fraction with a denominator of 63. This can be done by multiplying the numerator and denominator by 9, which gives a fraction of 27 over 63. Then convert 4/9 to an equivalent fraction with a denominator of 63. This can be done by multiplying the numerator and denominator by 7, which gives a fraction of 28 over 63. Finally, compare the numerators. Since 28 is greater than 27, we conclude that 4/9 is greater than 3/7. This works because converting the fractions to have the same denominator essentially means we're comparing the equivalent parts of the same whole. Sometimes two fractions might look different but are actually equivalent. Let's look at comparing 2/5 and 10 over 25. First, we need to convert to a common denominator for clarity. Although one way to see their equal is direct multiplication, let's find the lowest common multiple of 5 and 25, which is 25. To convert 2/5 to an equivalent fraction with a denominator of 25, we can multiply the numerator and denominator by 5. This gives us a new fraction of 10 over 25. Next, we compare the fractions. We see that 2/5 converts to 10 over 25, making them identical fractions. Understanding these steps is crucial as it helps in recognizing that fractions which appear different might actually represent the same value. By mastering these techniques, you'll be well equipped to compare fractions confidently and accurately. Let's dive into some examples to see how we can compare the value of fractions using the techniques we've discussed. Our first example looks at simple fractions with different denominators. Let's compare 3/4 and 5/8. First, find a common denominator. We need to express both fractions with the same denominator. The denominators here are 4 and 8. The lowest common multiple of 4 and 8 is 8. Next, we need to convert the fractions using the lowest common multiple as the denominator. For 3/4, we multiply both the numerator and denominator by 2 to get 6 over 8. 5 over 8 already has the denominator 8, so it stays as 5 over 8. Finally, we compare the numerators. Since 6 is greater than 5, 3/4 is greater than 5 over 8. Now let's compare 2/3 and 3/5 using a common denominator. The lowest common multiple of 3 and 5 is 15. First, let's make a common denominator. Multiply the numerator and denominator of 2/3 by 5, which gives us 10 over 15. Multiply the numerator and denominator of 3/5 by 3, which gives 9 over 15. Now we can compare the numerators. We have 10 and 9. Since 10 is greater than 9, 2/3 is greater than 3/5. Let's look at an example with more complex fractions. Let's compare 7/12 and 5/8. First, find a common denominator. The denominators are 12 and 8. The lowest common multiple of 12 and 8 is 24. Next, convert the fractions. For 7/12, multiply both the numerator and denominator by 2 to get 14 over 24. For 5/8, multiply both the numerator and denominator by 3 to get 15 over 24. Now we can compare the numerators. Since 14 is less than 15, 7/12 is less than 5/8. Using these techniques, we can accurately determine which of two fractions is larger or smaller. With practice, these methods will become second nature, allowing you to tackle fraction comparison problems confidently and efficiently. In today's lesson, we focused on understanding how to compare the value of fractions, a key skill in mathematics. We started by reviewing fractions and what they represent. We then moved on to exploring 3 distinct cases for comparing fractions, those with the same denominator but different numerators, those with the same numerator but different denominators, and those with both different numerators and denominators. For the first case, we learned that when fractions share the same denominator, the fraction with the larger numerator is greater. Visual aids like pie charts helped illustrate this concept clearly. In the second case, we discovered that with the same numerator, the fraction with the smaller denominator is larger, as it represents larger pieces of the whole. Again, visual aids were useful in solidifying this understanding. For fractions with different numerators and denominators, we introduced the method of finding a common denominator to make comparisons easier. By converting fractions to have the same denominator, we could directly compare their numerators. We also discussed equivalent fractions, demonstrating that fractions that look different can actually represent the same value when converted to a common denominator. By mastering these techniques, you can confidently and accurately compare fractions, a skill that is essential for both everyday decisions and more complex mathematical problems. Watch the rest of the GCSE Maths course at Sophos Education.